Okay, so you should have already watched the 2 videos about solving linear equations and linear inequalities. So now we're going to move on to absolute value equations. And again, the steps are out to the side. Notice they are different steps. Okay. Our first step in these guys is to get this absolute value quantity, this 2x plus 5 in the absolute value. Our goal is to get that stuff by itself, which means this guy, the minus 10, has to go. This guy, and times by -3, has to go. So let's do that. So first thing we're going to get rid of is the minus 10. We will be adding it to both sides. So that'll result in -3. We still have our absolute value quantity. Let's see, -6. Okay, now we need to get rid of that -3 that's being multiplied in the front. To undo multiplication, we know to divide by -3. So divide it away. Let's see, so we would have left just the absolute value quantity. Make that bigger so it doesn't look like a 12. And -6 divided by -3 is just 2. By the way, if this had been an inequality and we divided by a negative, we would have remembered to flip the symbol. But since it's just an equals, there is no flipping. Okay, so step 1, isolate the absolute value quantity. So we did that. We got the absolute value stuff by itself, nothing else around it. Then, notice I've got this step in the box up here. It says, after isolating, if the result is negative, stop. It's an equation with no solution. But this one is equal to a positive 2. So we don't need to stop. And we'll talk about why you stop on the negative on our next example. But since this is equal to a positive, we're going to keep going. So let's talk about this. In case you have forgotten, absolute value means distance from 0. So I'm just going to cover this up for a minute so we can think. I'll get rid of it here in a sec. So suppose I told you there's something with an absolute value, and the answer is 2 when you take its absolute value. Remember, absolute value means distance from 0. So what numbers have a distance from 0 of 2? There are 2 numbers. 2 has an absolute value, that's 2 away from 0. And also, -2 has an absolute value of 2 because it's also 2 units away from 0. So the stuff that could be inside of here, that stuff could be 2 or -2. So what we're going to do is now split, that's this part, split the equation into 2 parts, one for each number with a desired absolute value. So I'm going to split here and split here. This is a lot of writing. Let me simplify this a little bit. All right, we said this inside stuff could be 2 or -2, and those numbers would have an absolute value of 2. So we need the inside stuff. Remember that inside stuff, I know I scratched it out, but it was 2x plus 5. We need it to be equal to 2, or that inside stuff, which was 2x plus 5, we need it to be equal to -2 to make this true. Okay, so we've done step 1, isolated. It was not equal to a negative, so we kept going. Step 2 said split. So we split it for one equation for each of the desired numbers. And now we just solve like a regular linear. So on this first equation, let's see, we'll need to subtract the 5 away, which would leave us with 2x equals -3. Then to divide the 2 away, which would leave us with, let me scroll down just a bit. X is equal to -3/2, which is really the same as -1.5, although math teachers are not really a fan of decimals. For right now, it's okay with decimals, but as we get into things that are a little more complicated, fractions, believe it or not, are actually easier to work with. Okay, then we need to solve the second one. We need to subtract 5 from both sides here as well. So 2x equals, this time -2 minus 5 is -7. And then dividing by 2. So x would be -7/2. Or really that's the same as -3. Oops, I forgot my line. -3.5. Okay, so take a second and look back at this. So the hard part, if you want to say it's kind of, I guess it's the toughest part, is right here at this step where we are splitting into 2 problems. And again, that's all based on what number's out here. Okay? Let's do another one just to see what it looks like. So, same steps out there on the left. Our goal is to isolate the absolute value, meaning the 7 needs to go and the 4 needs to go. So let's take care of that first. So subtract the 7 away. That will result in, we'll still have the 4 and the absolute value quantity. Then we need to get the 4 to go away, so divide by the 4. That leaves us with just the absolute value quantity, and -4 divided by 4 is a -1. Okay, so we've done step 1, we've isolated. Keep in mind that little blurb in the box up there that says, after isolating, if the result is negative, stop. That's there. It's equal to a negative. So let's talk about that. Why? So we would stop and we would say this equation has no solution. There is no number that I can find for x that when I plug it in and take that, subtract 8 and take the absolute value, that I'm going to get -1. It's never going to happen. So let's talk about why. Again, I'm going to just scribble this out so we can think a little bit. Do you know a number that I could have inside that absolute value? A number whose absolute value is -1. And you may be thinking like, well, the absolute value of 1, but that's +1. Even if I get a -1 inside of my absolute value, it's still +1. There is no way to get an absolute value equal to a negative because absolute values make everything positive. That's why this is a no solution. Absolute values can never equal a negative. Okay? I'm going to flip back to the slide before. If an absolute value equals a positive, then that's possible. And then you keep going and you write out the 2 possibilities. Okay? If it's equal to a negative, stop. All right, we'll practice more with those tomorrow also.